So here we have an example and a way to use the logistic growth model. It says an influenza epidemic spreads through a population rapidly at a rate that depends on two factors. The more people who have the flu, the more rapidly it spreads, and also the more uninfected people there are, the more rapidly it spreads. These two factors make the logistic model a good one to study the spread of communicable diseases, and clearly there is a maximum value for the number of people infected, the entire population. So if you have a community that has 30,000 people, the most number of people that can get the flu is 30,000. Okay, so now we have an example. For example, at time t equals 0, there's one person in a community of 1,000 people who has the flu. Okay, so the initial number of people having the flu, the C over 1 plus A, that is 1. That's how many people have the flu to begin with. C is 1,000. That's the limiting factor. Our community only has 1,000 people, so that's the most number of people that can have the flu. Okay. Let's use this information right now to find A. So if C is 1,000, then A has to be, now you could do that algebraically, or you could think about it kind of logically. If it's got to be 1, I've got to have 1,000 in the denominator, and I need 1 plus, A is going to be 999. So you can think about that a little bit if you want to. Okay, and now we should have enough information to use our logistic model over here. So f of x is going to equal 1,000, that's C, over 1 plus 999 e to the opposite, and they tell us b. I forgot to read that part. Researchers find that for this particular strain of the flu, the logistic growth constant is b equals 0.6030. Now, the negative sign is in the formula, so it's going to be the opposite of 0.6030x. That is the model that we have, okay? X, remember, is time, so it's basing it on time. Estimate the number of people in this community who will have the flu after 10 days. So we're trying to find f of 10. Okay, so that's what it looks like when we're evaluating this. I might clean it up just a little bit here, make it a little bit easier to put in the calculator. It's going to be a big calculator thing. So I'm going to go ahead and multiply the exponent. That's going to give me negative 6.030, and that is in the exponent. Okay, so grab your calculator so we can put this in and see if we get it right. Now, what are we predicting? We're predicting how many people we think will have the flu after 10 days. Okay, in your calculator, you're going to put 1,000 divided by, open a parenthesis, 1 plus 999, and then you're going to push your E button, and it's going to have some kind of exponent thing with it. Mine does anyway. Your calculator might be a little different, but then you've got to put in that negative 6.030. Now we're expecting the population to increase, right? So more people getting the flu. Okay, let's put that all in the calculator and see what we get. We should get, it's about 293.85, but it's people, so we're going to round to the nearest person. So we think about 294 people will have the flu after 10 days. Not flu like that. Will have the flu after 10 days. I did it again, didn't I? The flu after 10 days. Now, it's a model. You know, you could count up the people who have the flu and it might not be 294. That's okay. It's probably going to be close, you know. This is just what we're predicting. Based on the logistic model, We're predicting that after 10 days, 294 people will have the flu for this particular strain of flu.